Question 23, it says S is a geometric sequence. Given that root x take 1, 1 and root x add 1 are the first three terms of S, find the value of x. So geometric sequence, I've just written an example up here, is where we multiply to get to the next term. So 2 times 2 gets to 4, 4 times 2 gets to 8, 8 times 2 gets 16, and 16 times 2 gets 32. Okay, I know that 32 divided by 16 is the same as 16 divided by 8, which is the same as 8 divided by 4, which is the same as 4 divided by 2. Okay, I'm doing this term divided by this term, I get my multiplier. This term divided by this term, I get the multiplier. This term divided by this term. So I end up, all of those are equal to 2, so I'm multiplying by 2 each time. Okay, so we're going to use that when we get here. So I know that root x plus 1 divided by 1 is the same as 1 divided by root x minus 1. Just going to wait, it's gone a bit blurry. Doesn't seem to correct itself. Okay, so I'm then going to solve to find x. So I'm going to put these in brackets. I'm going to, well, don't really need to multiply up by 1 because it will stay the same. And then I'm going to multiply up by root x, take 1. So I've got root x, add 1, multiplied by root x, take 1, equals 1. I'm going to expand my brackets out. Okay, so I've got root x times root x. So that's x to the power of a half times x to the power of a half. Remember, you add them together. So we've got x. One lot of root x is root x. Take away another lot of root x, so they cancel out. And 1 multiplied by minus 1 is minus 1. And we know that's still equal to 1. So x must equal, going to add 1 onto the other side, gives us 2. So we end up with x equals 2. Part B, it says show that the fifth term of S is 7 plus 5 root 2. So I know that the third term, that's the highest term I know from this first part of the question. I know that the third term is root x plus 1. Okay, I've worked out my multiplier now, okay, because each time, so how do I get from 1 to root x plus 1? Well, I must times something 1 times root x plus 1. So I know my multiplier is root x plus 1, but I know what x is now, so it's root 2 plus 1. Okay, so each term I move on, so up here my multiplier was 2, because I times by 2, times by 2, times by 2, times by 2. Down here my multiplier is root 2 plus 1, because we worked out the value of x. So to work out the fourth term, I multiply by root 2 plus 1. Fifth term, I multiply by another root 2 plus 1. So I'm just going to say, well, I'm doing root x plus 1. Well, we know what x is. It's root 2 plus 1. Okay, multiplied by root 2 plus 1 twice more. Okay, and when we've got triple brackets, we looked at how to deal with this. So you do your first two first of all. So root 2 times root 2 is 2. 1 times root 2 is root 2. 1 times root 2 is root 2. And 1 times 1 is 1. So before I multiply by my second bracket, I'm going to neaten it up a bit. So 2 add 1 is 3. Root 2 add root 2 is 2 root 2. Okay, next I can expand these brackets. So for your first, 3 times root 2 is 3 root 2. Outer, 3 times 1 is 3. Inner, 2 lots of root 2 times root 2. So root 2 times root 2 is 2. 2 times that is 4. So that was inner, and last. So we've got the last one in the bracket, so 2 root 2 times by 1 is 2 root 2. If I simplify that down, 3 plus 4 gives me 7. 3 root 2 add 2 root 2 gives me 5 root 2. This is what I was asked for in the question, so I can just put hence shown.